right, so lesson 1-7, composite functions. So how does each letter affect the graph of an equation in the form of f of x equals a parentheses bx minus c plus d? Well, a is going to be your vertical stretch. B is going to be your horizontal stretch. C is going to be your horizontal shift. And D is going to be your vertical shift. So that number times on the outside is going to make it taller or shorter. The number on the inside is going to make it wider or skinnier. But remember, it's opposite what you think. The C is going to shift it left or right. And again, it's opposite what you think. If it's minus, it goes to the right. If it's positive, it goes to the left. And the D on the outside moves it up and down. So, jumping into composite functions. It's going to be real important when we're dealing with composite functions. We find the domain of the equation, because there's going to be certain ones that don't work. Now, generally it's going to be if it's just x's on top, we're pretty much good. The only restriction we may have is if there's square roots, then we might restrict it so that we don't have negatives. But generally, if it's just something on top, we're good. When we have stuff on the bottom, we have to restrict certain things that will cause it to be zero. So, if we factor this out, we're going to get x and x minus and plus 1. So, if we solve those, x would equal 3 and negative 1. So that's what we have to restrict the domain. So it would be all reals except x cannot be 3 or negative 1. So it's just like in the past, in that first chapter when we were working with rational expressions like this. We had to restrict that domain so that there's certain x's that would cause the amount to be 0, and that causes problems. So we say, hey, it's going to be everything except these. These are those restrictions. That's what we're going to take away from the domain. Now, if we have just s of x there equals 0.22x plus 1, and we put 13, we're finding s of 13. We're putting that in here for x. So what we're really doing is 0.22 times 13 plus 1. And I don't know that off the top of my head. It's 3.86. Okay. So whatever's inside the parentheses, remember that's what you're going to put in for x, and then you solve it out. Now, with functions, we can do certain things with them, just like if they were anything else. So we can take the functions and we can add them together, and it's really just taking whatever the first function is, add it to the second. Same with subtract, multiply, or divide. Now, key here though is we have to exclude with the quotient what makes this bottom be 0. We can't have that happen because again we can't divide by 0. So if we start with our first one here, we're going to add the two functions. So putting like terms together. This one's got an x squared. We have 2x and an x, which would make 3x. A negative 1 and negative 2, which makes minus 3. Simple as that. We subtract them. So now the second one's being subtracted here, so this would be a minus x squared. 2x minus x would be a plus x. And negative 1 minus negative 2 would be a plus 1. Because minus and negative makes it plus a positive. If we multiply them, so we would have 2x minus 1 times x squared plus x minus 2. So here, and I'm going to move this up here. Here we're going to have to FOIL this out. So 2x times x squared would be 2x to the third. 2x times x would be plus 2x squared. And 2x times a negative 2 minus 4x. So we're going to distribute the negative 1 in. We have minus x squared, minus x, and then plus 2. So when we put our like terms together, we're going to have 2x to the third. 2x squared minus an x squared would just be a plus x squared, minus 4x and minus x, minus 5x, and then our plus 2. Now, when it comes to division here, we're going to have 2x minus 1 over x squared plus x minus 2. Generally, that's all you're going to have to do with it, because this bottom would factor out to x plus 2, x plus 1, x minus 1, x plus 2, x minus 1. Does not, so let me just factor here. So x plus 2, x minus 1. So will not factor with the top, so it's not going to reduce anything. That's the only thing we can look for is can we reduce it. But what we need this for is then we're going to say x cannot equal, well, if we solved here, we'd get a negative 2, and solve that one, we'd get a 1. So really don't need that for anything but those exclusions. So really, once you put them together, that's really going to be it, unless you can cancel a factor, but generally that won't be the case. So the domain for division won't include these numbers that cause the denominator to be 0. So if we put negative 2 in, or if we put 1 in, that causes it to be 0, so we're going to say, hey, x can't be these, and that's going to restrict that domain. Now, as far as true composite functions go, this is where we're getting to f of g, g of f. And really what's going to happen here is that second function is going to go in for every x of the first. So whatever g is, that replaces every x in f with that g function. So two things have to go on here. So the domain of the composition of function f of g is going to be the set of all x's such that one x is going to be the domain of g. So it has to work in G in order for it to work in its composite. Or composition, sorry. And then lastly, whatever we would get out of the function G has to be part of the dimension or domain of f. So the x has to work for G. It also has to work for the entire f, the whole composite as well. So if we look here, we're going to do f of g first. So what that means is we're going to replace, well, really there's just one x in f with this here function. So it'd be 3 parentheses, that x gets replaced with g of x squared minus 2x plus 6, and then it's minus 4, so we'll distribute the 3 in. So 3x squared minus 6x, 3 times 6 is 18, 18 minus 4 will leave us plus 14. So in this case, I should have pushed it up. So as far as our domain goes, really what we have to worry about is, do we have any x's on the bottom? Because then we'd have to restrict the domain. Do we have any square roots? Because that would make us restrict the domain. So we don't have any of those. So here it's going to be all reals for the domain. I'm trying to think if we have an example later on where yes we do. So I'll show you more of where that doesn't work here in a little bit. So the other side of this, we're going to do g of f of x. So now every x in g is going to be replaced with our f function. So x squared becomes 3x minus 4 squared minus 2 times x, so minus 2 times 3x minus 4, and then plus 6. So have to FOIL this one here. Let's slide back up. So 3x and 3x will make 9x squared. 3x times a negative 4 is negative 12x, and there'll be 2 of those. So minus 24x. Negative 4 times negative 4 would be a positive 16. Here we're going to distribute that in. So minus 6x plus 8, and then our plus 6. So if we put like terms together, 9x squared minus 24x and minus 6x would be minus 30x. And 16 and 8 is 24 plus another 6 would be plus 30. Okay. So back to talking about the domains there, those composite functions. So that last set there wasn't going to be anything to restrict with. So we really didn't have to worry about it. All x's are going to work. So all reals there. Now, here's going to be one where it doesn't quite work. So if we're finding f of g, first we have to look at what would not work with our g function. So on the g side of things, well, the only x that wouldn't work would be 0. So that's one thing we're going to have to restrict. The other thing is if we look at our f function, so whatever we would get out of this one to go into here, I mean, for one, if we look at our f function, if we put 1 in there, that would cause that to be bad things, right? So we're looking at where is 3 over x equal to 1? Well, if we times by x, so the x's cancel there, 3 would equal x. So we're also going to restrict it. So the overall f of g is going to be restricted by 3. So here it's going to be all reals except x cannot equal 0 and 3. So we looked at the g function first, what would cause it to be 0, and we're going to restrict it there. So if we look at our f function, well, 1's going to be the problem, but what we get out of g goes in for x. So even though 1 is what's the issue, we have to look at, well, what's going to make g be 1, so that when it goes in here it causes problems. Well, 3 over 3 is 1, so that's what causes problems there. So that's why I restricted how x can't be 0 and 3. Now, as far as decompressing functions, so the composition, we're putting them together. When we decompose it, we're pulling it back apart. So in this case, what are the two different functions that we're going to break this up by? Well, let's do an f of x and a g of x. So what could be the inside function? Well, kind of easier to see here with the parentheses. Inside the parentheses is a function. So I'm going to call that my g, which is 3x squared minus 4x plus 1. Well, if that's the inside function, what would the outside function be? Well, whatever's here raised to the 5th. So we're going to call this x to the 5th. So if we do f of g, we replace this x with this here, and we'd get that. Questions here, let me know. Otherwise, we'll talk to you guys later.